A year and a half ago, I built a custom e-bike to cover some of my family's transportation needs. Like many of my creations, it's unusual, maybe a little bit weird. It's been a huge success. In this video, I'm going to walk through what I built and why I built it the way I did. I like living away from town in the foothills, surrounded by more trees than people. The downside to this is the transportation requirement. Every trip is significant to my time, my wallet, and the environment. Building an e-bike is one of many ways of coping with this situation. I was pretty clear what my requirements for the e-bike were. I wanted enough power that family members would want to ride the bike, enough power to go up our 8% grade hill. I also wanted the pedaling ergonomics to be good. Let's get the most out of that human input. And lastly, I wanted it not to break the bank. I didn't care about the flat-out top speed. And thank goodness, I didn't care about meeting any fashion or aesthetic requirements. I was really tempted to go with some sort of gear drive system so that I could use a small, fast-spinning, lightweight motor. After more thought, I decided to not use gears that eventually wear out, gears that make noise, and decided to go with a super simple direct drive hub motor. I really value minimizing moving parts. The big disadvantage with a direct drive hub motor is its weight. They're quite heavy. And since I was wanting to go up steep hills, carrying a load fairly fast without overheating the motor, that meant I needed a quite big, very heavy motor. And this is a stretch for me. I've been a cyclist for long enough, it's hard to get out of the mode of counting every gram.
The motor I selected was the DD45 from Grin Technologies in Canada. Grin Technologies is the source for DIY e-bike builders. Really an amazing company, wealth of information, including really useful tools like online motor and charger simulators. Check them out.
Since my priority was hills rather than top speed, I wanted to lace this hub motor to a small diameter rim, effectively lowering my gearing. I have some frame building experience, and I did consider building a custom frame for this project, and this would give me all the flexibility. I could do rear drive if I wanted to. But since this was my first e-bike build, I decided I wanted to minimize my time investment in this project, and that meant minimizing custom fabrication. The small drive wheel was placed in the front primarily because of geometry considerations. I used a fork with a long axle to crown measurement to make up for the small wheel as much as possible. I knew that this configuration had plenty of drawbacks. Limited traction to the front because there's not so much weight there, funky handling with the front drive, and generally I like large diameter wheels, especially on the front. But for this application, I decided that the advantages outweighed the disadvantages to front drive.
With this configuration, I could use my existing freewheel and drivetrain and install a disc brake on the front, which is essential for a heavy bike.
The component that made all this work was a fat bike fork. The front hub width of a fat bike is 135 millimeters, which is standard rear hub width dimensions. This allowed me to put a hub motor that was intended for the rear in the front. And I was in luck. A friend of mine had a fat bike fork sitting not in use, steel salsa enabler fork.
The fork is strong and has lots of eyelets that I use to attach custom torque arms, a fender, and a small rack. The frame used was a steel mountain bike from the 80s, a Diamondback Ascent. The bike is rigid, has a 7-speed cassette and cantilever brakes. I mounted the shifter on the top tube to simplify and minimize the cables going to the handlebars. The front derailleur was eliminated, but the triple gears in the front retained. My wife and I find the middle 42-tooth ring just right. My 20-year-old son prefers the 46-tooth large ring, and the 22 tiny ring is good insurance to have in case I ever have to limp home without assistance. The motor controller selected was the Grinfinion 35 amp sine wave controller coupled with the version 3 Cycle Analyst, both obtained from Grin Technologies. The Cycle Analysts give great feedback on lots of data, speed, distance, power use, efficiency, and a whole lot more. The battery size was selected based upon a guessed efficiency of about 25 watt-hours per mile. I selected a 52-volt battery from EM3 EV, a small Chinese company with a great reputation. The battery has a hefty 1 kilowatt-hour capacity, weighing about 13 pounds. The most common choice for battery location for a front-drive e-bike is on the rear rack to even out the weight distribution. I had a hunch that the ideal battery location for my bike was as far forward and as low as possible.
I first tested it with the battery on the rear rack just to be sure. As guessed, the preferred position was up front for traction purposes. And it turned out having that small front wheel allowed space that I could put the battery on the downside of the frame's down tube.
I made a battery mount using 1-inch square tubing, 35 thousandths of an inch thick, that was left over from a previous project. I used tamper-resistant fasteners to give me a touch of battery security, being that the battery was the most expensive component on the project, about $500. The battery is easily removed from the bike, which is nice for battery storage in the wintertime. Below the battery, I mounted a small toolkit. It's really nice having all the heavy e-bike hardware very down low. Wide handlebars give control and stability to the bike. Finishing touches included pedals that work with a variety of shoes, a rear rack, fenders, mirror, and a bell. For charging, I purchased Grin's Cycle Satiator, which allows programmable charging options.
The bike is not fast, maybe 30 miles an hour on flat ground. It's terrible off-road, and it's not great on steep gravel roads. Being rigid, you have to watch out for potholes, stand up occasionally. Where it really shines is doing what it was intended to do, just going up that hill carrying a good load. The e-bike has really surpassed my expectations, needing no significant changes. The motor has a temperature sensor, and the temperatures have always run plenty cool. The efficiency of the bike has been so good that I could have gotten away with a smaller battery, but it's really nice to have more battery than you need. The bike weighs 65 pounds, including the toolkit, 18 of that for the motor, 13 for the battery. Another surprise is the value of the regenerative braking. I thought this would be pretty negligible, but it turns out for my hill, it's pretty significant. And it's possible to modulate the regen power. That's pretty cool. And because of the regenerative capabilities, I'll probably never have to replace my brake pads. They're used that seldomly. And the power is fantastic. 52 volts times 35 amps is 1820 watts, more than enough. And the handling is acceptable for those of us willing to pay attention. Pay attention to potholes, pay attention to throttle sensitivity, to that limited traction to the front. Speaking of pay attention, all of us e-bikers really need to pay attention to doing what we can do to get along with the other vehicles in the road. We're a new user group, and we need to earn good standing by really respecting others. The three things I really love about this transportation tool is that it's time efficient, energy efficient, and fun to ride. It's time efficient because I'm getting my exercise while I'm transporting myself. How energy efficient is it?
Somewhere in the range of 8 to 18 watt hours per mile, or about 77 miles per kilowatt hour, or 1.3 kilowatt hours per 100 miles. One trip to town in an electric car uses the same energy as 17 trips on the e-bike.
Another perspective is by using MPGE, miles per gallon equivalent. How far can you go with the equivalent energy of a gallon of gas? The MPGE of an e-bike is generally between 2,000 and 3,000. So about 100 times the efficiency of your average gas vehicle. Not bad for something that costs less than $2,000 to put together. Feedback is most welcome. Subscribe if you want more. And in your own way, turn towards the stuff that keeps you going.